Welcome all. Hi, I'm Frank Poncelet, and I have a problem. I like to build things. You were all thinking something else, right? But that's you guys. So I already said I'm Frank Poncelet. I run operations for Xplore Group in our office in Merelbeke. We're a Java consultancy group and an e-commerce group. Myself, I'm writing Java since 1.2, so that's quite a long time. And it's my 14th time at Devoxx. I'm also active in Devoxx for Kids. I did not put that on the slide. And the last few days, a lot of people asked me, that talk of yours, it has a pretty strange title. And so I will start with explaining you the title. So, yeah, you know the talk is about the cocktail machine, and who is very famous bartender? Well, that is Szyslak. So Szyslak is our bartender in The Simpsons. I'm a very huge fan of animation movies also. And there he serves Homer Simpson, Barney, and all the other guys. Now, another quality of our cocktail machine is it gets sometimes very grumpy. And we recognize that property in Szyslak also. He can be a little bit stubborn sometimes, sometimes run out of luck. I did that too, burned the pump yesterday. We'll go into deeper that later on. So that was one part of my title. Are there any people of Microsoft in the room? Okay, I'm going to make some Microsoft jokes, so I don't want to get eggs and tomatoes. So the second part of my title was the Balmer peak. So let's first talk. Who was Steve Balmer? Well, he was hired in the 80s at Microsoft. He did all kinds of stuff. Went CEO after Bill Gates and retired recently in 2014, well, with 42.4 billion. So he had quite an interesting career. But something that interested me about Steve Ballmer is he started the theory about the Balmer peak. And apparently he did experiments on that. And what does the Balmer peak say? Well, the Balmer peak say, if you're a programmer, actually your programming skill will go up if you have the right blood alcohol concentration. And it's just a little bit more than one beer. And yeah, apparently they experimented on that. My theory is that is how they invented the blue screen. But that is not confirmed by history. Okay, so that was it about my title. Balmer for the alcohol, Szyslak for the bartender. So what is the real agenda of this talk? Well, as I said in the opening, we are a Java consultancy group. We do e-commerce implementations. So why the hell did we make an automated bartender? We're not a group of alcoholics, so that's an interesting topic. When we came up with the idea, we first looked a little bit on inspirations. What did other people do? So I will show you some images of what other people has built. If you have been to the stand next to us, you will see our sister company, Sweet Mustard. They also have a bartender with them, which is a completely different design. So it's interesting to see the both machines working next to each other. Then once we've chosen, okay, this is the machine that we want to build, where you see the result here. And everybody who rates this talk with 5 stars can get a free cocktail after the talk at our stand. Don't forget. They're free for all others too, but it sounded good. Once we made our choice, what we're going to build is we said, yeah, we'll have to make quite a lot of design choices. We'll go into those into deep. And I did put the good, the bad, and the ugly, because the machine actually has some flaws that we detected, but we needed to build it first to find those. And we already have solutions for them, but they're not implemented yet. Then we talk a little bit about the build itself. And well, yeah, a company with 500 engineers, we have so many ideas to further improve that. I listed out our top wish list that we maybe do next summer, something like that. So that's the real agenda. So why did we make this? Well, we're a Java consultancy group, and what do we do most often? We write a lot of Java, and we upload that into the cloud, Google Cloud, AWS, Azure, whatever. The cloud is gone, runs beautifully there, client is satisfied and happy. And this time we wanted to really make something physical, something where you can actually see the code running. Because if the code runs here, you will see a pump running. You will see the liquids running to the tube. We looked around a little bit. There were a lot of options on physical machines that you can build with IoT that would have some practical use. But we have this concept, I have to say this in Dutch, sorry guys. We have this concept, 4:15 on Friday, where on Friday we close a little bit earlier and we have a beer. And yeah, mixing that with the physical machine, so we came up with the cocktail maker. It's completely outside our comfort zone. As I said, I'm writing Java since Java 1.2, so that's quite a long time. But you will see one of the design choices is we wrote this in Python. And I must admit, before I did this, I knew Python existed, but my expertise did stop there. So that was indeed outside our comfort zone. An IoT machine, physical machine. There was an interesting quickie here about an hour ago, learning through tinkering. I really believe in that. As I said at my opening, I said I love to build things. You can learn a lot by building things, because once it's finished, you will see your mistakes, you will learn from your mistakes. So by building it, it gave us a learning experience. And yes, of course, because we can. It's a cool machine. We have seen it at the stand. So usually at 4 o'clock, we put in the tubes. People see the lights running, people come, people think it's a quite cool machine. So that is why we did build this machine. So where did we get our inspiration? Well, where does everybody get his inspiration? We did go to Google, and we said automated cocktail maker, images, and then you get something like this. I really did want to build the one on the left with the robot arms. There was something similar on Supernova recently, but yeah, it's one, you can't really build that as a software consultancy firm. You need a lot of hardware, and they're too heavy. This thing weighs nothing. Somebody else from our group, he really loved the one with the rotating bottles, but it's mechanically quite difficult one. Then the one at the bottom right, that is the one that you will see at our sister company, Smith Mustard. They built one like this, which is also an option. And then you have the top one, so the one with the pumps. And yeah, you can already see what we have decided to build. So we really love the idea of having these pumps and seeing the liquid go through the pumps, through the tubes, to your glasses. So okay, that was a decision, and we're going for the pump design. Next thing I did is I hired a student to come and help me, because yeah, we have to work for clients, so the engineers in the office don't really have so much time to work on this full time. So I hired a student that came to help me for 1 month. He will actually come back quite soon to do his master thesis on something on AI. And that next thing we had to do is let's make our design choices. Because yeah, we've seen some machines on this side. Yeah, wood, didn't really like the wood. The other one, mechanically very complex. The one on top there, an open design. So we like that. So what design choices? We did go for V-slot beams. I will go into detail in all the menu points in a minute. I will show you the electronical design. I can already reveal it's a Raspberry Pi running. Then we had the peristaltic pumps. We've already seen those too. We did go for Python. We did go for something very exotic called Flask. And the Neopixels, those are the lights that will color our bottles. So the open design was quite important because, yeah, this is not a machine that we say we want to put this in production, we want to go to bars and sell it. It was really because we can, because we're interested in building it, and so on. So we wanted this open design that everybody can actually come and look inside. You can see the tubes, you can see the wires. And yeah, the V-slot beams there, you can get them in all dimensions and all sizes. They're really easy. They're aluminium, so you can cut them quite easy. They have one disadvantage if you ever build something with V-slot beams. I also promised you to give you the disadvantages of our design choices. If you look at the beams, you will see that the hole inside the beam, that it has, that the sides are angled. And everything on the beams you have to connect with M5 screws. And the M5 nut doesn't fit inside the beam. So you have to buy special nuts to go inside the beam. So that was a disadvantage. Okay, you can easily get these at the same manufacturer that makes the V-slots, of course. But we miscalculated the first time, so we had to put in a second order for more nuts. So that gave us a little bit of time delay. You can only put the M5 in there. If you come later on and you come and see the machine, you will see the pumps. They are attached with M3s, so they don't fit on the tubes, so we had to 3D print all kinds of adapters. So the V-slot beams, they're light, they're easy to handle, easy to cut, but they do have some disadvantages too, like the nuts not fitting, and yeah, they're not accepting anything else than their own designs. The open design, we also went for plexiglass, so a friendly company did laser cut those for us. We did not have a laser cutter, so we did go to another sister company that had a laser cutter that did cut all the stuff for us, so it doesn't get too dangerous because there's quite a lot of electricity in there. And we don't want people to put their hands in there, so we did put some plexiglass to finish off the V-slot beams. Okay, let's go maybe a little bit more technical. Who is here an electronical engineer? I am. No, not so few, only a few. Okay. Well, basically, this was our first electronical design that we made. You can see we chose for a Raspberry Pi. At this moment, it still could have been an Arduino. But we said, yeah, let's go for the extra power, and that was a good decision at that moment. Because in this design, you will still see that we selected an OLED display. But the OLED display, it was so small. You could hardly use it. You could hardly see what you've selected. So quite fast, we said, no, let's go for this 7-inch HDMI display that's in there. And there we really needed the power of the Pi to power that display. A few buttons. You only see 3 on the front panel here. There are 2 more hidden buttons in the back where I can put the machine in an administration mode, because at the end of the day I need to clean the tubes and do the maintenance of the machine. I don't want to offer you that if you're at our stand to put waters in the tube. You guys are coming for alcohol, so no water. So I can turn those off with the 2 hidden buttons in the back. On the front, you have the 2 yellow buttons where I can basically make my selection. And I have the green button where I can say, this is the cocktail that I want. So they go straight to the Pi. This is the original electronical design. What did we see? The 2 hidden buttons there are on this side. They're quite close to the Pi. The 3 other buttons, they're quite far, over a quite long cable. And we did get glitches. So we added, and you can, if you come later on, you come and look in the machine, you will actually see them. We added low-pass filters to remove the glitch of the cable. Probably using a higher quality cable would have solved that too, but yeah, this also works. What else do we see? A relay board, 8 relays, going to 8 pumps, with, of course, our flyback diodes that when you stop an engine, that the current doesn't run backwards. The Neopixel, so we did put, think about 65 Neopixels on here. I'll talk about them later, but they're really cool because basically every RGB LED in here I can give its own color whenever I want. And they're really cool to use if you want to make something fancy, you want to make a special Christmas tree this year. Well, Neopixel is definitely the way to go. What else do we see on the electronical design? Well, we have our power supply here. The power supply only delivers 12 volt. I need that 12 volt to run the engines. But the Pi and the rest of the electronics needs 5 volt. So there's a very small power regulator in front too that will deliver the 5 volt for the Pi and for the Neopixels. And basically that's it. Yeah, we used Fritzing to make the design. So you see the breadboard. The breadboard was replaced here by a power distribution board. But basically, except for the 7-inch display and the low-pass filters, nothing changed anymore to this design. Oh, I have to run. Next, well, the choice of pumps was basically was a very interesting thing, and it gave a lot of constraints to the design. The peristaltic pump, it's a pump that was invented for people that have kidney disease. They need to have their blood filtered. So they use them in hospital. These are cheap Chinese things. These are not the hospital grade stuff. But they gave us two very important advantages. So the liquid, whatever we put in here, it will never touch any of the mechanical parts. So you cannot complain next week that you got grease in your cocktail or oil or something like that. It's simply not possible with these types of pumps. And the second advantage of these pumps is if you let the engine make one rotation, I almost exactly know how much liquid did go through. And definitely precise enough for a cocktail machine. And yeah, there's also the two advantages why they use them in hospitals. An interesting disadvantage, if you look on this side of the machine, you will see I doubled out the pumps. Yeah, this one should not be here. The two bottles that are here are Coke and tonic, and they are carbonized. They have CO2 in the liquid. And what do we see when we pull up the liquid through the pumps? The CO2 gets released by the liquid because I'm sucking on a straw. And that disrupted the pumps a lot, and that basically did not give me the accuracy anymore. Because of the air bubbles in the tube, there was just not enough liquid running anymore, and so the machine had to run for a quite long time. So we doubled out these pumps. They did not really solve the problem. At the end of the talk, I will give another solution, but we did not have the time and the tools anymore to implement that solution. But yeah, just running the pumps faster, because that's basically what I'm doing, did also solve the problem partly. Because if you come to the stand later on for a cocktail and you take something with Coke, you will actually see it makes the bubbles in the tube. So that was a big disadvantage basically of our primary design choice, where we said we're going to do it with the pumps. Yeah, carbonized liquids, it really gives a problem. So yeah, if we look at the sweet mustard designs where the bottles are the other way around, you don't have that problem there. Now, as said, I do have a solution for that, but I'll tell you later. For the rest, yeah, as I said, we used relatively cheap pumps. I already burned one pump here at the convention. Specifically the pump unit. The engine is still okay, but the pump unit. So probably have to go for a little bit high quality pump like we see here if you do this on your own. Another choice we did make is these are very, very small pumps. So if you come to the stand later on, you will see that it will take some time to make a cocktail, but that was intentional. We really wanted the machine to show the machine that it's working. If you use big pumps like the one that's on the screen right now, the cocktail would be there in 5 seconds, and you would be gone with your cocktail, and I would not have the time to talk to you. So that was intentional. Another interesting design choice that we did make is to use Python. So Python, built in '91 by Guido. And it's not, as I did put our in uppercase. I think it's for, who knows Python here? Oh my God, too many people. I have to be careful what I say. It's not really our native programming. If I look at our company, we're mainly doing Java. We're doing a little bit of PHP. There are some people that are doing a little bit of Python and other languages, but it's really not our native programming language. And then if I look specifically at the team that built the machine, basically we had no Python knowledge. So that was an interesting challenge for us. I had the statement there, if you can program in Java, you can basically learn any language. And I think we did it. So there are still a few glitches in the software, but it works quite well. And oh my God, for us was, if you type Java and you say, wow, I'm lazy today, I will not format my code very beautiful, it will still work. Python uses indentation to mark your blocks. And I will later show some example. So we don't have curly brackets, and the position where your code line begins is actually important. And we were so not used to that. So we got a lot of errors when you run it's an interpreted language. So when you run the program, it said, syntax error, your indentation is wrong. So what? So that was really, really interesting. But we also saw a lot of things that we did know. So we have imports in Python. And in Java, you import a class or a package. Here you can easily even import a whole framework. One of the frameworks I'm importing here is the GPIO. That really works well. I can recommend that if you ever use a Pi and you want to use it as an IoT device, you want to use these input-output lines, the GPIO library is really, really good. A lot of configuration, we're used to that from Java, we do in JSON. So we needed a JSON library. If we look at how the software works, basically, there is a database in there. It has a whole set of cocktails. And when we start it, it will read the JSON, or I can use it programmatically, but I will tell the machine on pump 1 you will find gin, on pump 2 you'll find tequila, and so on and so on. It will make a select on the database, and it will only offer what it can make. It won't, we didn't bring the tonic, so it will not offer you a gin tonic. It's just not there. It offered that, you select it, then it goes back to the database and say, I want to make a gin tonic. And I think the database will say back, okay, you use 1/3 of gin and you'll use 2/3 of tonic. And for that, I will basically spawn 2 threads. I will spawn a thread for the gin pump, which will run, let's say, 20 seconds. And I will run a second thread on the tonic pump, which will then run for 40 seconds. We know that the constant RPM, how much they pump, they will pump it over here. It will come in a glass. Dorina will be so nice to add some ice, and you have your gin tonic. So the imports, it was something that we did know. Let's have a look at that indentation. So we don't have curly braces. That's interesting. So a for loop, like we're really used to write in Java. But you see the double dot at the end, so there's no curly brace there. And there is one line that is indented a little bit. That is the code block. If I now move the second line, the self.pixels, if I move it to the same indentation as GPIO, it will also be inside the for loop. So no curly braces. That's interesting. This is basically a pump configuration, the standard pump configuration in a JSON format, like it sits in the machine. And you see, I can actually, I read that in the read pump configuration. I read that in, and basically it makes a complex object where I can just ask, okay, pump configuration, that's in the for loop for pump X, give me pin 18. Pin 18 is an output line, and I'll put standard and high on there. If they go low, the pump will run. But the indentation was an oh my god for us. It was really not that easy. Yeah, a little bit about that GPIO. We had a lot of problems with this. As I said, probably because we should have used a better quality cable. The GPIO library, it has built-in debouncing, but we still had glitches over the cable. If I would touch another button, that it would actually glitch through. But only a little bit, and the low-pass filters really helped there. I still have another problem. I haven't solved it yet, so maybe something for our Python specialists in the room. When I spawn the threads, when I make the cocktail, I will remove all event listeners. I'll let the threads run. When the threads return, I will put the event listeners back active. And what do we see? Sometimes the event is not gone. It's still in the queue, and he makes a second cocktail. Now here on the event, that's not that bad, but in the real world, that would be an annoying thing. So far for the Python. Then we'll go to Flask. And Flask, basically, it's a micro framework for Python to make a web interface. So as I told, we did put this 7-inch HDMI display here. I didn't want to go all native and stuff like that on that display. So we said, let's make a web interface. So we have a Firefox running. We just remove the header of the Firefox, so it runs full screen. And we have this web interface that you can control by the buttons which cocktail you're going to drink. Now, yeah, it's a BSD license for people that want to use it in their own software, so that's important. And you can just do pip install Flask. Pip is the standard Python installer. It will pull it in. And let's have a look at some code. So Flask, in the code, app.root / yeah, it is from my index page. We all know that, right? That's also how we do REST services and so on. It has an annotation, you give it a root, we give it a method, and the method in our case goes to something that is called /drinks, which is a template. And yeah, I did put some rudimentary exception handling around that. Then let's have a look at the template. And the template really reminded me of something. That's why I said I'm writing Java since 1.2. If I look at this, I think GSP. I really think GSP. We don't do that anymore. We have React, we have Angular. We don't do GSPs anymore. But we even have a scriptlet in here. Remember the scriptlets in GSP? You could write Java code inside the HTML code. Well, it's there. It's right there. So with the double curly braces, I can just get variable names from objects. And with the curly brace %, I can actually start writing a scriptlet. I actually did remind me of my previous job. Sorry, guys. Where we had a lot of scriptlets inside the GSPs. So this was really familiar for us, and that worked really fast. Because yeah, we have quite a lot of front-end engineers that could also help a little bit out left and right to give some advice to our student. So I think the web interface really worked out nicely. What was next? Well, next was the Neopixel. So the Neopixels, they come like this. Pieces of 1 meter. There are all kinds of form factors, but these are the ones that we used. Pieces of 1 meter. They have RGB LEDs. And actually, you can give every RGB LED a different color at any given moment in time. Here we're trying it off an Arduino, but basically for the Pi, it's the same. It's a very simple interface. It has a data line, a clock line. It has 2 power lines, and you're off. If you come and watch the machine later on, you will actually see, because you can cascade these. We did use 2 rolls of this in the machine, and they're just cascaded one to the other. And the Neopixel takes care of all that himself. There's the nice library from Adafruit that powers these. So this is the Python code again. So as said, I have a data pin, I have a clock pin. I have to initialize the Adafruit library, saying, yeah, I have so many pixels. That's my pin, that's my data pin, that's my clock pin. Then basically I say self.strip.begin to initialize it. And I can give a maximum brightness. I think we put it at 60-something%. And then I can start playing magic with it. So I did copy-paste from somewhere else a small for loop where we turn all the LEDs off. That's what we do when the drink is ready. First we turn them all green, we leave that on for a second, and then we turn them all off. So just a for loop over all the pixels. I put them all to 0. Nothing will happen. And at the moment that I then say self.strip.show, it will actually execute that on the hardware that is in the pixels itself. So you can actually update every pixel to give it a state that you want. And then when you hit the show, it will show that state, which is pretty cool. If you, let's say, I want to make a super huge screen like this one with LEDs, you can actually start moving your LEDs all the time and just refresh it at a 25 frames per second rate, whatever. So you can actually do this with these strips. I think we didn't do enough with the strips. We can improve the code later on. Basically now it runs as a sort of a progress bar when we're making the cocktail. It turns green when the cocktail is ready. We gave it a small drip out period. And when the green goes out, you can take your cocktail out. And then the LEDs turn off and it waits. So there can be a little bit more show element that the LEDs will also do something when the machine is running idle or something like that. But if you want to do a first project, say make the best Christmas tree ever, Neopixel is definitely the way to go. So if we take all these design choices together, well, we come to this machine with the Rena next to it. Like this picture was taken yesterday or the day before at our stand. It's a little dark. But basically, this is it. Control panel, one side, HDMI on the other side, the Pi inside. And yeah, a lot of alcohol to go with it. So we also, as I already talked, there are some interesting improvements that we can still do to that machine. So a first improvement definitely is fix the carbonized liquids problem. I already told you that I would give you some solutions. We looked up some specialized pumps, but reading further on it on the internet, they all say don't do it, it won't work. So that's why we doubled the pumps now. Another option would be to basically pressurize the bottles. So then the pump will no longer function as a pump, but it will function as a flow regulator. And you give pressure, enough pressure that the liquid will go up in the tube itself. That's one option. The other option is indeed to turn the bottles around like in the other design. But also then I need some kind of flow regulation because of course I need to get the right amount of Coke, of tonic into this one. So there's definitely two things that we're thinking about. I really want to fix that. I'll probably go for the last option, where we say let's put the bottle the other way around. Because pressurizing, that would mean putting a soda stream bottle next to the machine, having a pressure regulator, building adapters for the bottles that have to fit on every bottle and that can actually withstand the pressure. I don't think 3D printing there is a good option because the pieces will explode in our face. So that's also, so you have to manufacture special parts. So I'll probably go for the reversed bottles there. And then the interesting part, well, let's put some AI on the machine. And yeah, there were a lot of ideas, and some of you actually in the room gave me also quite some ideas during the event. An interesting there is cup vision. So, we didn't bring one. We have these really beautiful cups at the stand with our logo on it. But of course, that cup has a very specific form. It's merchandise. Now, if we say we're going to put this in a club or something, then I want a gin tonic in a gin tonic glass. And I want my, my dry martini in a dry martini glass. And actually putting a camera on it, the machine would be able to see what glass is this? How much volume can this glass hold? Because if we would go deeper into the code, we don't have time for that, but if we would go deeper in the code, you will see I give the machine a parameter where I say, all glasses are about this size and just fill them. And now this AI would be able to dynamically change that parameter depending on the glass that you put there. So that would be putting a camera on the cup. A second thing that it would see is, right now I still have this problem with the carbonized liquids. So I'm not really sure how much he is pumping. I'm guessing, but I'm not really sure. Of course, most cocktails only have one carbonized liquid in it. And for the rest, they're mainly alcohol, which is not carbonized. So looking at the cup, I could actually see how much I'm adding. And as I'm sure how much alcohol I'm putting in, with the camera, I would be sure that I fill the glass to the exact level that I need. So that would also be an option for the carbonized liquid problems. Another problem we still have with this machine, and I had it with some of you, is you ask a gin tonic, and we give you the gin tonic, and you drink of it, and you say, whoa, it's a strong one. And then I say, oops, sorry, I didn't notice that the tonic bottle was empty. And you got a semi-pure gin. So a second camera, maybe even two, can actually watch the bottles and to warn us that bottles are going empty. There are different options to do that too. There are all kinds of fuel level metering systems, but the camera with the AI would also be an option. And then the last one, well, let's put a lot of cameras on this thing, is basically user vision. So I'm a beer drinker, so the machine won't learn that much from me. But if somebody comes back regularly and he will say, okay, that is definitely is a vodka orange guy, he could remember you. And the next time you come back, he will offer you a vodka orange as first choice. And you can still change it by the menu, but he can sort the menu with what you like to drink. He might even go further. And you might even pull statistics, because a lot of AI vision protocols now can say, this is a happy guy, this is a sad guy. So I can recognize you and I can recognize your mood. And I can say, if you're sad, you're drinking a Long Island iced tea. And if you're happy, you're drinking a screwdriver. So I can really dynamically start building the menu based on those things. So those are our first ideas for improvements. They're definitely possibly a lot more, but it's a first start, maybe for next summer. Voilà. So that basically concludes my talk. So we still have about 10 minutes left. So if you have some questions, I would say, shoot. And don't forget to rate me a 5-star for that free cocktail at our stand. Any questions? No questions? Oh, sorry, I didn't see you. Yeah, go ahead. Yes, that is why I have one of the hidden buttons. So there's a hidden button where I can basically put the machine into a maintenance mode. That's something we do every evening here. Probably for the alcohol bottles, it's not that important. But like for the orange juice and the Coke, it's sticky stuff. So every evening and every morning, we clean the machine. And it has that mode. Yes, it's foreseen. Anybody else?
electronic diagram, you had a lot of pins being used for the various things. Did that dictate this number of modules that you could support and the number of pumps you could support?
Yes and no. If I want to, let's take the electronic design quickly back. We still have some time. Here we are. Basically, there are 2 spare lines. So I would say no, I can add 2 more pumps, but then I'm out of lines. But if I can always say 2 lines is enough. Because 2 lines, I can hook up an Arduino. I can even hook up an Arduino Mega next to that. So I can go infinite on the pumps. But then of course, for this electronic design, 2 more pumps, I'm done. If I say, no, I really need more, let's add an Arduino. It will be powerful enough for the pumps. I said that the choice of the Raspberry Pi was lucky because we changed from the OLED to the HDMI, so that was lucky. Even an Arduino was enough for this machine with the OLED. But with an Arduino, if you say I go for a Mega, you have so many lines, so no. Infinity is the option. Multiplexers would be other options, but I don't think I would go that way. So I'll probably put in an extra processor on Arduino if I need more than 10 pumps. Anybody else? We still have 8 minutes left.
Have you considered putting the bottles on a scale instead of using a camera to see if they are?
Yes, it was another idea. Yes. So the question was, have you considered just weighing the bottles instead of looking at them? It is definitely an option, but it also has a problem. Because if I take this bottle when it's empty, and I take this bottle when it's empty, they don't weigh the same. And you can say, yeah, but you can tell it because you told the machine when you booted it, line 4 has the vodka and line 1 has the gin. But there are so many different gins also. So if I tomorrow, and this is quite good gin, it's the Hendrix one. If I tomorrow go for another brand, it will be a different bottle with a different weight. So I will have to somehow get empty bottles. That's relatively easy, drink more. And then weigh them and then start putting a database on knowing what is an empty bottle.
You're now defending the camera solution with an opaque bottle.
Yes, indeed. Every solution has its pros and cons. Yeah, go ahead.
It looked like you had an API for accessing the pumps. Is that right? Does the pump come with an API?
No, we just use the GPIO. I don't have that part of code. If you come to the stand, I can actually show you the part of the code that controls the pump. Which slide am I showing? This is the configuration one. No, I don't have this part of the code inside, but we're only using the GPIO part for the pumps. And we basically, as I told, we look at the recipe, we get the numbers, we spawn a thread per pump that we need, and that thread will control at that moment that pump. But it just says GPIO 17, go low for 17 seconds. That's basically all that it does. Another thread will control another pump. When all threads return, we know the drink is ready.
Does the pump just switch it on, then you decide when to switch it off? Or do you tell the pump to have an instruction set which allows you to say switch on for 17 seconds?
It's the thread that is the pump has no intelligence at all. It's our constant RPM pumps, so we're pretty sure they're running at, have to look, I think it's 1200 RPM, something like that. And we know each rotation does X milliliters. I don't know it by heart. And so we're really calculating that to seconds or to milliseconds. And the thread controls that. I still have room for one more. Any last question? No? Okay, then I invite you all at, I think at 4 o'clock, Dorina. We'll put the lines back in the bottles and you can come for a free cocktail. Thank you very much.